Okay, so let's look at 2.8, solving for a specific variable. You've already solved equations, so solving for variables is the exact same, but let's see what that really means. So here on this first problem on the left, we got then is this is what it used to look like. So we got 2y plus 4 equals 8, and we'll solve this just like we always have. We'll take 4 away from both sides. You'll be remaining with 2y on the left and 4 on the right, and then we can just divide both sides by 2. And the whole idea is, well, if you're looking at this, you realize y is not by itself, it has other things with it, and we have to incrementally get things away from it. And so in that case, y was 2. Now let me see if I can pan this over. Now here's the deal. I was able to just straight up relocate that as though nothing had happened. So let's take a look at that in a moment. But here we have the other problem where we have 2y plus 4 is equal to x. So just like in the first one, we realized that y wasn't by itself, and in these problems we would be told explicitly to solve for y. It wouldn't say solve for x in this problem, because if it did say solve for x, we would be done, because x is already by itself. But I know that I have two things that are by y, and one of those two things is the 2, and the other is the 4. So we always would subtract first for these problems, so I'm going to take 4 away from both sides, which is really the exact same as what we did here. And then on the left side, the exact same result happens. I have 2y is equal to, but instead of being able to just write 4, because we had 8 earlier, we now have x, so I'm going to have to write x minus 4. And then lastly, just like before, we would divide both sides by 2. And we have two ways we can write this. You can either show over 2 and then over 2 as an in-between step, or we can just take that entire part and write it over 2 like that. But notice that my fraction bar goes under everything there. So pretty much everything is the exact same as far as the steps go. On the left side, all I have remaining is y, and I'm going to write x over 2, but since I can divide 4 and 2, and since there is a minus sign there, I'll go ahead and write x over 2 minus 2. And that's a done problem. So, jumping into the problem, now again the first one was done to show that the whole then approach is really the same as what you're doing now. It's just that it feels a little bit strange because you're solving for a variable. And let's ask ourselves these questions. Looking here, how many variables are there? 1, 2. And then how many total equations? 1. And since there's more variables than there are equations, that means that this may not have just one solution. It will mean that it has possibly infinite solutions. Okay, so we have 3x minus 4y is equal to 7, and we're told to solve for y. So first of all, is y completely by itself? Well, no. And you can start these any of a bunch of different ways. But for this one, I'm looking at the left side, and I see that there's 3x, and then there's minus 4y, and then over here I have 7. For me, I'd really like to get rid of that 3x first. And because it is a totally separate term, broken apart by a minus sign, and I know that it's positive to begin with, I'm going to subtract 3x from both sides. So that on the left side I'll have negative 4y is equal to, now I like to write the variable first, so I'm going to rewrite that as negative 3x. I know that a 7 is positive there, so I'm going to write plus 7. And then now I'm going to go ahead and divide everything by a negative 4. This time I will show it separate just to show you the variety. And what remains on the left side is y is equal to 3/4 x. And I'm treating that as positive because these signs flip. And then I'm not going to write plus 7 over negative 4. I'm going to write minus 7/4. If my teacher was fine with it, I could have just included this as 3x minus 7 over 4, and that would have been fine too. But later on, when we do slope-intercept, this is going to help you see that the slope is 3/4 and that the y-intercept would be a negative 7/4. So there's reasons for showing the work both ways. For now, we'll just leave that sort of loose. Number 2 tells us that 15 is equal to 3n plus 6p, and we're asked to solve this for n. And when I look at this, I see that n is on the right side of the equation. It is not by itself. It has times 3 as well as plus 6p going on. So for us, we're going to start this by subtracting 6p from both sides. If you're comfortable with it, we're going to write negative 6p plus 15 first, the negative 6p, and that will be equal to 3n. And I should always scan through these as I begin these, make sure nothing disappeared. That came down. That came down. So that takes care of everything that was on my left side. This went away. That's why it didn't show up over here. And 3n did come down on the right side. You know how I like to keep my equal signs straight? Here I kind of don't have a choice. I didn't have enough room. That's acceptable for this problem. Now we're still trying to solve for n. So I'm going to realize that n is totally by itself, but it does have that 3 out front. And since that says 3 times n, I'm going to get rid of it by dividing everything by 3. As an optional in-between step, I'm going to show that I'm writing just n. If you don't want to do that, you can jump down to this final result where you're going to write n on the left side. So I have negative 2p because 6p over 3 becomes negative 2. And then 15 over 3 becomes positive 5. And so that I'll now have n is equal to negative 2p plus 5 once I rewrite it left to right, showing the n all by itself on the left. Before we get into these more complicated problems, let's keep it as it is and see how you do with some practice on your own.